Okay, number 6 says in both parts of this question, x is a real number and theta is between 0 and pi. And it says by completing square, find in terms of theta the minimum value of x. The minimum value is x varies. And this is looking at it, really not that bad to look at. Let me get my highlighter out. I'm looking at this over here, which is parabolic in form, by the way. And this is a parabola. And there's going to be a parabola that opens upward. And how do I know that? Looking at that, the coefficient on the x-squared term is 9 positive. And the cosine of theta between 0 and pi goes back and forth between, minus 1 and 1, all right? And so I'm going to say it's clearly a parabola, by the way. I'm looking at the other function, too. They're giving me another one over here. And that's a fourth degree polynomial. A little more complicated, but we'll do that one as well. And they say it's a maximum value. And that stands to reason, by the way. And I'm looking at it, it's, minus 9x to the fourth. So it's going to be like sort of like a thing that opens downward. We'll go through that in stages, by the way. So I'm going to do part A. I'm going to go to the whiteboard to do that, by the way. And let me put it on the whiteboard. I'm going to look back over my notes, by the way. I'm going to get a pen out. And I got the pen out. And let's write this down. So I'm going to say my first function I'm looking at is 9x squared minus 12x cosine of theta plus 4. And by the way, I clearly notice a parabola. Opens like this over here. Now, the vertex can be moving around depending on cosine of theta, but I want to remind you that theta is between 0 and pi. All right? So what I'm going to do is, as they said, I'm going to try to follow their instruction, by the way. There's other ways of doing it. I'm going to factor out a 9, because I'm going to complete the square. I like the coefficient on the quadratic term to be a 1. Makes it easier for me. And what would you get there? I think you get 4/3, right? Because 3 goes into 9 3 times, and 3 times 4 is 12. And I can write this as cosine theta now, times x. And then the 4 I'm going to put over here. What do I do now? I got to take half of the coefficient on a linear term and square it. Well, half the coefficient will be minus 2/3 cosine theta. And if you took half of that and squared it, what are you going to get? You get 4/9 cosine squared theta. All right? And put little parentheses in this over here. Now, the problem for a lot of students, what happens is, me too, I forget sometimes what I just did. And I move on. Mistake, by the way. But really, what am I doing? I'm adding 4 cosine squared, so we got to take them away. So minus 4 cosine squared theta. All right, let me keep going. And this is going to be 9. They say complete the square. I've done that. This will be x minus 2/3 cosine theta squared. And then over here, I'm going to factor out a 4. And you're going to get 1 minus cosine squared theta. I'm going to try to neaten this up a little bit. This is going to be x minus 2/3 cosine theta squared plus 4. And 1 minus cosine squared is probably better off writing it down as sine squared. So now I know where my vertex is. And again, I want to point out the vertex on this thing is an opening upward parabola is a minimal point. And where's that going to be? Well, x would have to be 2/3 cosine theta, and the y would be 4 sine squared theta. And again, I want to remind you that the theta is between 0 and pi. So this thing over here, that would be between, it would be on the interval from 0 up to 4, not touching it. And this guy over here, and the cosine goes between plus or minus 1 interval, it would be going between minus 2/3 and 2/3. All right, so I know they're going in a box now. The x values would go between minus 2/3 and 2/3, and the y values would go between 0 and 4. The next one's more difficult for me. And the reason why it's a fourth degree polynomial at this point with some parameter in it. All right, let's write this down. I'm going to write f2 now. And what's that going to be equal to? Well, I got to look back on my notes. I have to write it down. 12x squared sine theta minus 9x4. And what's interesting about this over here, it's a fourth degree polynomial. The sign is always going to be positive in that region between 0 and pi. So really, I'm kind of looking at something that's going to look sort of like this. It's an even function where there'd be two roots at the origin. That's x equals 0, x equals 0. Then there'd be two other ones that are symmetric. It's an even function. And it would look sort of like this over here. And there'd be a maximum there, a maximum there. And they say I can do this by completing a square too, by the way. So let's give it a shot. And the way I'm going to do that, I'm going to factor out a -9. And again, the reason I do that, I like the coefficient on that, degree term, the fourth degree term, to be positive to help me complete the square. And it's going to be -4/3 sine of theta x squared. And then I'm going to put a little parentheses over here, and I'm going to complete the square now. Half of that number, with the coefficient on the x squared term, by the way. And this is like I have a u squared minus 4/3 sine theta u, where u is equal to x squared, by the way. So I'm really completing a square. That's all I'm doing. And what's that going to be? 2/3 minus 2/3 squared, you get 4/9. And that's going to be sine squared. Now, what I did was you think I might have added on, I actually subtracted it, so I got to add it on now. And what's going to be added on? Well, 9 times 4/9 is 4, so it's going to be 4 sine squared. Let me write this down. This is -9. And then what do you get? You get x squared minus 2/3 sine theta, quantity squared, plus 4 sine squared theta. I know these maximal points now, right? Now, where are they going to occur? Well, certainly the y value is going to be 4 sine squared theta. And the x squared value, I hope you realize that the x squared is going to go over here. Now, when I say the x, this is still going to be an x value here. I'm not going to solve for it, though. What would it be? It would actually be just 2/3 sine theta. It's where this that square term is taking out a 0, by the way. So then I got a problem now. I know there's a parabola. I know it's fourth degree polynomial, and I'm kind of curious about where they meet over here. But obviously, if they're going to meet in two separate locations, by the way. How do I know that? I'm kind of looking at their y values, and their y values are agreeing for all theta, by the way. But the bottom line is I want to make sure that I want to get the x values to an agreement, by the way, as well. And how do I do that? I got to realize I'm looking at something, and I want to point out this is x, and I want to square that guy. And the reason for that, I want that to be x squared so I can match with the other guy. So I really want x squared equal to this guy's square. Well, that means I want 2/3 sine theta. That's what x squared is over here. And what's the other x squared going to be? It's going to be 4/9. I'm expecting to see two of them, by the way. Cosine squared. Okay, I got some problems over here. One of the big problems I have is I want to get rid of the coefficients, make them integers. And I can multiply both sides by 9/4. And what would you get there? You get 3/2 sine theta. I still got a fraction, don't I? Cosine squared. I'm going to multiply both sides by 2. I get 3 sine theta equals 2 cosine squared theta. Before I forget, I want to remind you, theta is between 0 and pi. I want to solve that equation to find out, what those points are. And those points are x and y, by the way. Let's take a look. I'll probably do a graph later, by the way. I'll do it by, I'll post the graph also along with the document so you can look at that. I want to get in terms of one function, so 3 sine theta, 2, this would be 1 minus sine squared theta. That's quadratic in form. I'm hoping it's going to work out nicely. So you get 2 minus 2 sine squared theta equals 3 sine theta. And I'm going to write down 0. You know what? Maybe I should do something a little different than that. Zero to sine squared theta plus 3 sine theta minus 2. I'm going to hope that factors out nicely, by the way. And I'll put this down. So 2 sine theta sine theta. I'm going to say 1 and 2. And it looks like this over here. Let me just check it, by the way. I get 2 sine squared. 4 minus 1 is 3. Yeah, it looks great. This has no real solution, so I'm not going to bother with that. But I'm looking at this 2 sine theta. And when does it equal to 1? So sine theta would equal to 1/2. So I don't want to draw the picture for you. The picture is between 0 and pi. So the sine function looks like this over here. That would be 0. That would be pi. This is the number 1. And 1/2 hits it twice. So there's going to be 2 angles where this happens. And I was expecting that, by the way. Why is that? I'm expecting to get 2 points of intersection, by the way. So when does the sine theta equal 1/2? Let's go through that. I would do a little triangle for you, reference triangle. And that would be 1, that would be 2, that would be root 3. What's that going to be? Well, that's 30 degrees, right? And what's 30 degrees? Well, 30 degrees is equal to pi over 6. All right? Now I want to point out that's this angle right over here, which is going to be pi over 6. What's this angle over here? I want to point out it's got a reference of 30, so it's 150. So it's going to be 5 pi over 6. All right? So I'm going to claim that this parabola, F1, let's write this down now. I got to go back over and look at it because I don't want to just keep scrolling. It's F1's going to be 9x squared. And let's do the first theta, by the way. Theta equals pi over 6. We'll just do this one first. So 9x squared, let's see, minus, well, I want to point out it's minus 12x cosine theta plus 4. And if you get the pi over 6, by the way, the cosine of that is going to be root 3 over 2. Let me write that down for you. So you can get minus 12. Whoops, I went too far there, didn't I? So it's minus 12 times root 3 over 2. That's what the cosine of that angle is, by the way. What would that give you? It would give you minus 6 root 3 x plus 4. All right, that's fine, by the way. All right, and if you did the other one, put down theta equals 5 pi over 6. What's F1 going to equal? Let's write this down for you. 9x squared. Well, if I'm in the second quadrant now, it's going to be the cosine is going to be negative. So I'll write this as plus 6 root 3x plus 4. And you can graph those two parabolas out, by the way, and they're going to look like two parabolas. I mean, they're certainly going to be different parabolas. They're going to look like parabolas, by the way. Let me do the other one, which I think we also had a 4th degree polynomial. I got to look back over my notes to write that down. I can't remember it. I think I called that F2, by the way. And what was F2 going to be equal to? 12x squared sine theta minus 9x4. I'm also going to verify the points for you too, by the way. And I'm going to say, if theta is equal to pi, I think I said pi over 6, right? Yeah, pi over 6. What are you going to get? F2 would be equal to, well, the sine of pi over 6 is a half, so you can get 6x squared minus 9x4. And if the theta is 5 pi over 6, F2, it's still going to be the same thing, by the way. It's still going to be, this is theta, it's still going to be 6x squared minus 9x4. All right? So I'm going to say, yeah, I'll graph those out. I'm not right now, but I will graph them out later. But I want to go back and talk about the points now. All right? And I want to talk about the vertex right now. And the vertex, you got two different thetas, by the way. And we're talking about the parabola, by the way, pi over 6. And the vertex is going to be what? Well, remember, the cosine of theta for pi over 6 is going to be root 3 over 2. So you're going to get 2/3. Let me write this on the side, by the way. Let me write over here. 2/3 times root 3 over 2. The 2's cancel. And I'm going to write as 1 over root 3, by the way. And what's the sine of that angle going to be half? And so you square that, you're just going to get 1. Because 4 times that is going to be 1. Let me make sure that's true. Half would give you 1/4. Yeah, that looks pretty good. And what's the other one going to be? Well, the theta would be equal to minus 5 pi over 6. And again, this gives this vertex over here. What vertex do you get over here? Well, you're still going to get 1, right? What do you get for the cosine? No, you get minus 1 over root 3. All right? Let's do the other guy. And I'm expecting to see the same thing, by the way. I'm really expecting to see the same exact thing. All right? What are the points going to be? Well, I want to point this point over here. This point over here is going to be 1 over root 3, comma 1. What goes over there? Minus 1 over root 3. And we're expecting to see that symmetry. All right? We know we get those points over there. Just checking this out. I hope you realize that's 4. And then how do you get the x? Well, you got to plug it in. And what's the sine of theta? In both cases, it's going to be 1 over 2. So x squared, again, if the sine theta evaluates to 1/2, this would just be 1/3. You're still going to get 1 over root 3, plus or minus. So we're getting these points over here. And that's a good thing. So we have an idea of the visualization of this over here. The question there, I want to see if I've answered it all. I got to go back and read it. But we did the completeness square. We found the form of the minimal point, and then we did the fourth degree polynomial. We also found the form of that one. And again, these things are going to agree at some point. We did that, and I think we did okay. We'll go on to the next question next. Thank you for paying attention.